Hello guys, welcome once more. It's Jamb Physics 2013 question, and we shall be looking at question number 1 to number 5 in this series. Now in this edition, we shall be looking at very fantastic part of physics that will so much interest you, and at the end of this video you will have learned quite a lot of things. Now don't forget that my name is Dami, and if you learned something from this video, click on like button. We have more content to share with you that will better help you analyze physics. Now let's go to number 1. Number 1 says man, so unfortunately number 1 is not there. It says not accessible. So that means in the past question there was no number 1 question in that year. Now maybe it's not in the year, maybe it's a typographic error. Number 2, now when a brick is taken from the Earth's surface to the moon, its mass what? Now what happens to mass? What if you take something like somebody decides to take, okay, this is a brick block, I want to take this brick to the moon, and then the man weighed that brick, and the brick was on the earth, it was 20 kilograms. Now when you get to the moon, what will be the mass of the brick? Do you have any idea? Will it remain the same 20, or will it reduce or increase or become 0? Now actually, we've learned from year 1 SS1 that when something goes to the moon or anywhere it goes to around the world, the masses don't change. That means the mass in the, like this is what I have here. This is something here, weight on the earth. The mass is 10 kilograms. What's the mass on the moon? The mass on the moon is still 10. Now the mass also in space is still 10 kilograms. The mass never changed. The mass remains the same. But look at the weight. The weight on the earth was 98 Newton, but the weight on the moon was what? It has an extremely small weight on the moon. I mean, it is lighter on the moon, but in space, what's the weight? It is weightless. But things on the moon have little weight, but things on the earth have extremely large weight. So that means that this is my parcel. On the earth, the mass remains the same as on the moon and as in space, but the weight varies. That's why things float in space. So if you have if you take your house to space, your house is going to float in space. Do you know why? Because the weight of the house is 0. Okay, so it floats, but the house remains heavy the way it is heavy on the earth. It has the same mass, so the mass of the house remains the same. Like if you are floating in space now and the house too is floating, and you say let me carry the house, you can't still carry the house. The house is still as difficult to carry as ever, but it can float because it has no weight but it can still be lifted because it has mass. So the mass remains the same it was on the earth, but the weight is not the same. So if you are floating with the house too is floating like it has no weight, but the house is as heavy as you, but you cannot carry the house because the mass of the house is still the same, but the weight of the house vary. Okay, so that's what we have in space and on the moon. Mass remains the same, but weight vary, and that's the answer. It remains the same. Number 2, the resultant of two forces is 50 Newton. If the forces are perpendicular to each other and one of them make an angle of 30 degrees with the resultant, find its magnitude. Now there are two forces. Now there's one standing straight, there's one going this way, F1, F2. Okay, now if they have a resultant passing through them like this, okay, 50 Newton, right? And one of them has angle 30 to the resultant, right? I use the one below, angle 30 to the resultant. Now what is the magnitude of that force? So if because it is an horizontal force, you use cos, so it will become 50 Newton cos 30. So any horizontal force is uses cos, not sine. Please take note. Anything horizontal uses cos, while anything vertical uses sine. So that means the force will now become 50 cos 30, and the answer will now become 43.3. If you put it in your calculator, that would be 43.3. So the resultant force is 50 Newton. Okay, if the forces are perpendicular to each other, and that is the answer to that question. So the answer to that question is 43.3 Newton, and that is just it for number 3. Let's check out number 4 now. The pair of physical quantities that are scalar only are what? Now, which ones are scalar? That means all the others are vectors, but there's one that is pure scalar. Now, volume and area, are they scalars? Scalar quantities are quantities that have only size or magnitude, but they have no direction. While vector quantities are quantities that have both magnitude and direction. So now, number one says volume and area. Volume and area are both scalar. That means you can only say volume as in, you can say only the volume of the drum is 50 centimeter cubed. That is volume, but you can't say direction because volume has only scalar. It does not have, we don't see direction for things that we are measuring their volume. Then also area, you can see that the area of the room is 200 centimeter cube. Okay, but you can't say 200 centimeter cube in this direction. So option A is scalar only. Volume and area are scalar only. Momentum is and moment are both vectors. Length and displacement. Length is scalar, displacement is vector. Impulse is vector, time is scalar. So the one that is both scalar are option A, volume and area, and that is the answer to the question. Number 4, the pair of physical quantities that are scalar only are, so the answer to number 4, I've given it already, is option A. Number 5, a simple pendulum of length 0.4 millimeter has a period of 2 seconds. What is the period of a similar pendulum of length 0.8 millimeter at the same place? Now, when you have a pendulum, now you know there's this thing that you say about pendulum, like you have a pendulum bulb. Oh, I didn't put a picture of a pendulum bulb. The longer the bulb, the longer the rope, okay, that's the more the length of the rope, the more the period of oscillation. That means you can see from the formula, period T is directly proportional to length. So the more the length, the more the period. Okay, now, and that means that I'll just solve. Now this question is between the length of the rope and the period all the time. You know, period is the time it takes to complete an oscillation. Like if I have a pendulum bulb at this point, if I push it this way, the time it will take for the bulb to go this way and come back and return to that point, that's one oscillation is completed. That is the period. Okay, now the longer the rope, the longer the period. Okay, so that means if the rope is this long, if the rope is very short, if it's not very long, okay, the period of that it will only oscillate for a short time. But if the rope is very long, it will oscillate more. So the more the rope, the longer it oscillates. That means the more the period. But the shorter rope will have lesser period, and that is it. So the formula is here. For anything period on simple pendulum, you will use this formula. T equals 2 pi root L over G. Okay, and that's, but the question is, but because our question is between period and length, we just bring out the two of them. Period is directly proportional to length, right? And the two of them are on a straight line on top, so they are both directly proportional. That will give me directly proportional will become equals K root L, and therefore my K is therefore T1 over root L1 equals T2 over root L2, right? And that is what I will get. So now this is the formula I will use to answer the question. So I'm finding what is the second period, that's period 2. Now then T2 will now become, if you multiply and you divide both sides by L1, you'll be getting T1 times L2 times root L2 over root L1. And that is the formula you use. Now plug in the parameters. T1, what's the first period? The first period is 2 seconds. And the second length, root L2, that's root 0.8 over root L1 is root 0.4. Okay, now then I have this. If I turn this into fraction, that will be root 8 over root 10 over root 4 over root 10. Root 10 cancel root 10. I have less root 2 times root 8 over root 4. Root 4 in root 8 is root 2. So the answer is 2 root 2. And that is my answer. 2 root 2. And don't forget that anything pendulum, when it comes to period, the master formula, or I always say that the strongest formula in anything simple harmonic motion is T equals 2 pi root L over root 2. That is the strongest formula in simple harmonic motion. Please don't forget. And that is the way to go about finding the period of the pendulum. And that brings us to the end of this video. Don't forget, if you learn something from this series, I want to get more content that will better help you understand, click on the like button and we'll get to reach you with more content that will clarify a lot. Until we see you guys, take care of yourself and bye for now.